Building fires can affect everyone. There's little or no warning, and it can all happen so very quickly. Simply, a poor electrical connection is all it takes, and rarely do we know this is happening until it's too late. These days, many types of electrical fires are successfully prevented by equipment installed to protect it from taking place. These safeguards are found in our electrical distribution boards. However, there is one very subtle cause which has to date enjoyed no means of prevention, and it is called the high resistance connection or joint. Well, that is until now. What you are about to see is a simple and quite amazing demonstration of how this unique and new to the world Australian innovation works. It simply uses a tiny but very clever component which is placed within these devices at the factory of manufacture, which works with another protective switch, which is probably already installed in most distribution boxes, the RCBO, sometimes called a safety switch. Most electrical fire risks stem from poor or loose connections in plugs and sockets on the power circuits, also from the switches within the distribution boards feeding them. As lighting is invariably quite low powered, the risk of fire from these circuits is low. However, because there are always far more plugs and sockets than anything else in a building, as well as many connections in the distribution boards feeding them, this is where there is greater and well-proven danger. As well as plugs and sockets, and especially in the United Kingdom and Ireland, where instant hot water showers are highly popular, this introduces another common cause of fires. A pull cord switch is used to isolate the mains electricity from the shower unit, and loading is so great on these little switches, there have been an enormous number of incidents which prove the point only too well. In the videos, we'll demonstrate very simply, firstly the component working itself when it is not installed in the sockets or switches. We'll then show what can happen if there is no thermal activator fitted inside the socket or switch. And finally, we'll reveal how much safer these accessories are when the PIP component is embedded. It can clearly be seen here a socket which has no load plugged into it, whilst the socket downline is loaded. The unloaded socket, although it appears not to be used, still starts to catch fire whilst the loaded socket is working properly. The reason for this is because the load on the used socket is downstream to the one burning. But how is this, you may ask? It is simple, because the loose ongoing connection to the loaded socket is joined inside the unused unit and has a poor connection at the back with the incoming and outgoing wiring. Here you can see the results of a bad connection in a short period of time, which may have far more devastating effects over a longer period. Here can be seen what happens to the trip if this component or its surroundings become hotter than 85 degrees Celsius. 85 degrees Celsius is not hot enough for anything to catch fire, but it's far too hot to be working properly, and it's on its way to becoming far worse. Therefore, it simply cuts the power to that circuit, removing all risk. Furthermore, it will not permit the trip to be switched back on until the dangerous socket has been replaced and the wiring repaired by an electrician. This is a very simple and self-explanatory video demonstration of which we've used a heat gun to provide the high temperature. In this last demonstration, both the socket and switch have the component embedded, therefore they are safe if a high resistance or poor connection occurs and excessive heat begins to take hold. Here we have a typical shower pull cord switch that would generally be located in a bathroom. These switches are supplied with a cable that has enough power to supply 2 cookers. 10% of shower pull cord switches have poor connections and will fail, or worse, due to the limited space and terminations of the cable. Again, for simplicity, we have used a heat gun as a thermal source, which clearly shows the isolation trip switching off when the protected accessory reaches 85 degrees Celsius. Modern electrical regulations worldwide favour and mandate the use of safety switches, such as RCBOs these days. With these already widely being present in most up-to-date distribution boards, And with the same device, along with this single small component and nothing else required to so obviously reduce massively the fire risks associated with bad connections, why wouldn't anyone wish to obtain and have fitted these types of protected electrical accessories? With the take-up of accessories embedded with PIP or pre-ignition prevention technology raising the level of the RCBO's virtue from preventing electric shocks to also preventing a very common cause of fire, why not remove an entire level of unnecessary risk so simply?